Question number 9. A solutions architect needs to design a secure communication channel for transferring sensitive data between an Amazon EC2 instance and an S3 bucket. Which combination of actions should be taken to ensure data is encrypted in transit and never leaves the AWS network? We're looking for 2 answers to accomplish these tasks. Our first option is to enforce SSL, these days we call it TLS, for all S3 bucket requests. This is the underlying security technology that lies behind the use of HTTPS communication. If you use a website that asks for your credit card number, you're going to look for that little lock symbol in the corner that tells you that it's an HTTPS-based web page. What we're saying is we want that same kind of communication between an EC2 instance and an S3 bucket. That's an option that I can configure in an S3 bucket policy. I can allow communication with that bucket if secure transport is enabled, which is another way of saying we're using TLS. So that sounds like a good fit. How about Amazon Macie? Amazon Macie is a security technology that looks inside of your S3 bucket to see if it contains anything that should be better protected but isn't. That might be personally identifiable information. It might be financial data of some sort. It could be credentials for an application to be able to go log into some secure resource. Anything that probably shouldn't be exposed in an S3 bucket, Macie will flag that for you. That's a nice way of ensuring the security of the contents of our S3 buckets, but it neither encrypts data in transit or keeps data inside of the AWS network. So we said enforcing SSL or TLS these days will give us the encryption in transit. Macie, probably not what we're looking for. How about implementing server-side encryption with AWS KMS? KMS is the key management service. It supports the creation of the encryption keys that support a variety of different encryption technologies within AWS. This is another tempting distractor because we are being asked to identify a way to be able to provide encryption in transit. If you know that KMS involves encryption, that might be a tempting answer. But encryption of the sort that KMS supports is encryption at rest, not encryption in transit. KMS supports data that is in an encrypted state in storage. Here, I want to make sure that as it travels from one device to another, in this case, an EC2 instance to an S3 bucket, that data remains encrypted. KMS, although tempting, is not our answer. Our fourth option is to restrict S3 bucket access with IAM roles. Roles are all about temporary assignment of permissions. If I want to give my EC2 instance permission to talk to that S3 bucket, using a role is a great way to enable that secure access using temporary credentials that will evaporate minutes after they get used. That's a great security best practice, but once again, it neither helps ensure data is encrypted in transit, and it has nothing to do with whether that traffic can leave the AWS network. So, while an important part of the solution probably, it's not an answer to this exam question. And that leaves one more option, to configure a VPC endpoint for S3. VPC endpoints are a very interesting capability. AWS services in many ways act like they are their own private companies, where EC2 is a business over here, and down the street is a business called S3. By default, an application running in EC2, if it's configured to retrieve data from S3, assumes that it needs to get data from S3 the same way that you and I would get data from S3, which is to say, we'd reach out to the internet and connect into S3 using its public internet-facing endpoint. And that is a perfectly valid way for an EC2 instance to get data from S3. EC2 could contact the S3 service via its public endpoint. S3 could send back the data that was requested. The instance now has that data. But if you look at it from another perspective, it looks a little bit silly. Because in many cases, that EC2 instance and that S3 bucket live in the same AWS region, which means they probably live in the same availability zone. They might physically occupy the same building. In which case, why wouldn't we just communicate over the AWS network that connects the devices that make up these services? Why would we go out to the internet just to turn around and come right back into what might be the same exact building? Noteworthily, that is not a default. You need to deliberately enable that if you want it. And it turns out the mechanism that allows an EC2 instance to reach outside of its VPC and reach into other services in that same AWS region is called VPC endpoints. And it has the very nice benefit of making sure that that traffic does not leave the AWS network. That's particularly handy for those of us that have a regulated workload that insists that certain data must never touch the internet, not even in an encrypted form. If that's the case, a VPC endpoint is that side door that allows me to reach out of my VPC and into another service while staying inside of AWS's network. So, enforcing TLS on our S3 bucket requests ensures that data is encrypted in transit. Configuring a VPC endpoint for S3 makes sure that that traffic never leaves the AWS network. Those are our two answers for question 9.